All right, guys, so on Friday we stopped by talking about these things called linear regressions. Um, linear regression just basically means whenever you take data and you try to fit it to some kind of a function. One more piece of paper. So in real life, data doesn't always line up exactly well with a particular function, but it can get close. And so what we do is we find what's called the line of best fit. So what we're going to do today is we're going to do this two ways. One way is we're just going to eyeball it and kind of get you guys used to the process of understanding how to draw it, how to come up with an equation. But then we're going to actually use the graphing calculator to get a precise answer instead of an estimated answer. Okay, so that's it. Tomorrow we're going to have an in-class review day. So basically, we're going to be splitting you guys up into groups. I'm going to give you a study guide for your test, and we're going to spend the whole block just kind of prepping for your first test. Wednesday will be like, it'll be your first part of your test, but if you guys don't remember your test in here, you have like a free response question where it's not like multiple choice, and it's also something that makes you think a little bit. It's not meant to be easy. But I do let you guys work together for a certain portion of that again, okay? And then on Thursday, we'll take the actual test. And then on Friday, we'll begin our next unit. So that's our plan for the week. So let's go ahead and finish up our last lesson here on linear regressions. We talked about the correlation coefficient as well. I also told you we're not going to really spend too much time on it. I might throw a homework question or two at you about it, but as far as finding the correlation coefficient, probably won't be asking you guys to do anything like that. But what we talked about was that the two variables you're looking at when you do a linear regression, they're either related to each other really strongly or they're not. The closer they are to a 1 or a -1, the stronger that relationship is. So we looked at this chart too, right? So in this case, you end up with such a straight line, we would say that they have a very strong relationship, and since it's going downwards, that's negative. Whereas over here, the two variables, the y and the x, have a very strong linear relationship in the positive direction. But then if they start to get scattered apart, you start to lose it. So notice these things are getting further and further away from 1. And by the time you get to r equals 0, right in between 1 and -1, it's pretty much just such a mess that you really couldn't draw a line to represent the data, which means those two variables really aren't related to each other, at least with a linear function. So we talked also about how linear regression is not the only kind of regression. You could have other types of regression. So sometimes a different function will fit your scatter plot better. Okay. We're only going to do linear in here, but your calculators, you'll find, when we get to there, you'll see buttons for all different kinds of regression. So we're going to go ahead and start one here. I believe was this printed for you on your guys' notes, example 2? Okay, so it says we're going to estimate the equation of the line of best fit, and then we're going to determine if you would classify the relationship as positive, negative, strong, or weak. So here we go. If I want to draw a line of best fit, you guys, I'm sure you guys could do that just fine. Basically, you want to draw a line that goes through the data that they give us as closely as possible. So like maybe like right about there, right? That sound reasonable? All right, so there's my line of best fit. Now I want to find, oh, it got moved. Sometimes that happens. All right. So now I want to find the equation. So if I want to find the equation of a line, what do I need to do, guys? We need some points, right? Now there's a lot of points up here. So which points should I pick? You want to pick something that's actually on the line. The ones that are closer to being on the line are better. Now, we have a lot of different points to choose from, and you will get a slightly different answer based on which points you're choosing. Why? Because we're not getting an actual answer here, we're getting an estimated answer. And so depending on what point you pick, you're going to get a different estimation. All right. So let's go ahead and just pick some here, and we'll estimate what these values are. What would you guys? Let's go with this one right here. What would you guys estimate that point to be? What's the x value look like to you? 165. And about what would you say the y value is? Okay, so they're about the same. Are you guys noticing, by the way, I didn't think to mention this, but look at the variables. We're talking about your height and your arm span. And what we're trying to do is trying to figure out, you know, an equation that represents a way to connect the span of somebody's arm length to their height. All right, so we have one point here, 165 and 165. Let's pick another one here. Let's do this one right here. It looks like it's nice on the line. So what would you say that x value looks like? Get to estimate here probably. 170?
No,
177? So something close. Yeah, because if this is 65, you know, this is 180. Maybe we would expect like 170 to be like about here, and then a little bit more, like maybe like 170. Let's go with 175 just to make it easier. 5 are a little bit easier than 7. What would you say the y value would be there? Probably about the same once again, huh? So we drew our line, right? We picked 2 points. Now what do I do if I want to find the equation of the line? Find the what? Slope. Okay, so that would be, going to use your formula, right? Some of you may not need to. You may already know what the slope is here, but I'm going to go calculate anyway because it's not always so easy. So we do y2 minus y1 over x2 minus x1. And that's 10 over 10, which is 1. So my slope is 1. All right, what do we do after we find our slope? We find our y-intercept. Now, there's 2 ways you guys could find your y-intercept. One is you could just look at it and estimate it, right? Can you guys see where it's touching the line? That's probably going to be the easier way. But we could also do the thing where we plug in the x and the y and the slope to get it. So let's go ahead and we'll just estimate it by, well, actually, you know what? Let's go ahead and calculate it. I'll tell you why in a second. I just realized something. It's not obvious. All right, so let's go ahead and use this x value here, 165. So I'm going to plug in 165. My slope is 1, 165, and b. What will b come out to be here? 0. Now, does this look like 0 to you? No. Anybody got a good explanation for what's going on there? Yeah? I didn't notice it until I was looking at the, so when I was saying we could do it by the equation or by the graph, I kind of quickly did it in my mind with the equation, and I realized it didn't match the graph at all, and now I kind of know why that is. Somebody kind of see it? Well, here's the reason. How far apart are these 2 numbers here? Those are 15, right? How far away is 150 from this spot? Does that look like the same distance to you? So this is 150 and this is 15. This should be like way bigger, right? What did they do when they drew this graph? They just cut off anything basically lower than 150. Does that make sense? And so is this really the y-intercept? No, the y-intercept will be like way back here somewhere. So we can't actually see it. So the way they drew it, it's a little deceptive. So just to be on the safe side, let's go ahead and just calculate it. Okay. So that was an interesting little side note, but let's stay with the basics here, right? Draw a line, pick some points, find your slope, find your b. And so now we have the equation, right? What would the equation be? Y equals just x, right? What's the slope? 1, and the y-intercept is 0. So you could just say y equals x if you want to. And so what does that mean about arm span and height? They're pretty much the same, right? Whatever your arm span is, that's what your height is. Okay. So this is the answer to the first part of the question. It said find an equation of the line of best fit. Would you guys say that this is a positive relationship or a negative relationship? It's going up, right? I turned my 1 into a P. That was a weird. All right, so it's a positive relationship, right? And what that means is that as your arm length gets bigger, your height should be bigger as well. Okay, they both increase at the same time. Negative means that as one gets bigger, the other goes down. Okay. Would you guys say this is a strong relationship or a weak relationship? Now that's kind of a difficult question. So let me clear my board here, and I'll bring it back in a second. But how about instead of strong or weak, based on this, -1, +1 are really strong, right? Where would you guys say this one's falling at? It's positive, right? So we know it's somewhere over here. Would you guys say it's more like a 0.8 or more like a 0.3? So we'd say 0.8 might be a good R value there. Would you say it's stronger than 0.8 or about the same? Looks about the same. Okay. So that would be a pretty strong relationship. We'll go ahead and estimate the R value. Why not? Can't hurt. So we'll say fairly strong. And what that R value tells you basically is that arm length and height are pretty strong predictors of each other. So in math, we like to talk about how strong the relationship is, because then we can know how dependable the prediction is. So like you can know that, well, if somebody's arm length is this much, there's a very strong probability that their height will be such and such. Okay. If it's a weak relationship, like 0.3 or 0.2, well then you say, well, there's a relationship maybe, but it's so weak, I don't know if it really predicts it very well. Yeah. So this is all estimation, guys. There's not a precise answer to this stuff. It's all just estimation. All right. So we've got our steps up here. You might want to label them because this was a very long example. Okay. So the first thing we did was we found our points. Well, actually, the first thing we did was we drew a line, right? Then we found our points. Then we did our slope, did our y-intercept, wrote our equation, and then classified it as positive and gave it an estimated R value. All right? You guys think you can handle one of those? We'll throw one at you and see how it goes. Can I erase? Sounds like a yes. Okay. Did I print this for you? I didn't, did I? I did. Yeah. Nice. Okay, great. All right, so now answers will vary, but we should all be close to the same thing, okay? So answers will vary because it depends on what points you pick. So go ahead. Okay, so since there's not just one answer here, what I'm going to do is I'm just going to ask you guys to share out your answers, and I'll tell you if they're reasonable or not, okay? So first of all, I would sketch a line of best fit right about here. So in other words, what are we trying to do when we do the line of best fit? We're trying to find the line that gets closest to all those dots as possible. We want to get as close to those dots as possible. And you know, we don't want to favor some dots more than others. Like for instance, I can make this line get really close to, I can make this line get really close to those two dots on the bottom, but that's not fair to the rest. You kind of got to think you know, like you want to make sure everybody gets a fair share of the line. So you want to put the line that gets closest to all the dots. Okay. All right. So that's a good line of best fit there. So I'll call on you guys and have you guys share out your all right, your answers with me. So Quinn, I'm going to skip the points because everybody might have picked different points, but I'm going to go ahead and ask for your slope. What did you get for your slope? That's pretty reasonable. Amaya, did you get to do this? Yeah, I'm not sure if we came in a little. Okay. Amber, what did you get for your slope? Huh? 1/0? You know what? I bet you were close, but my guess is that you did the I bet you did the x's on the top when you did the y2 minus y1. And the reason I'm guessing that is because if I flip this over, what kind of slope would that be? This would be a zero slope, and zero slopes look like a flat line, right? And that's almost a flat line. So I would say that hers, you know, that's not a terrible estimate. I would like to see it be a little bit positive because I do see a little bit of an upward trend, but overall not too bad. So we'll say 0/1, getting the idea, but I'd like to see some positive rather than 0. How about George? Not here today, huh? Oh wait, no George, right? All right, Edward, what did you get for your slope? 1/9? Sure, that works. I even saw somebody who's like 1/16. It could work. All right, let's look at some b values. Nicole, what b value did you get? 2.5. Did you calculate it or just look? Cool, nice job. Madison, what b value did you get? Okay. Jason, what was your b value?
2.
2. And you calculated it? Yeah. Okay, good. Yeah, so if you calculated it and you got something that looks a lot like what it actually looks like, then you can be confident that you did something well there. All right. So there's my equation. Y equals, I don't know, I'll just pick one. 1/7 x plus 2, right? Something like that. Lolly, is this a positive relationship or a negative relationship? It is positive. Amanda, what R value did you estimate? Amanda D. What R value did you estimate that at? Yeah, probably another point. I'd say it's pretty close to the pointing. So it's a pretty strong relationship, whatever it is. We don't know what these variables represent on this one. We're just kind of guessing. All right, so now at this time, I'm going to have you guys go ahead and make sure everybody gets a graphing calculator. We have quite a few people here. So why don't we do it this way? Why don't I have you guys all come up and grab a calculator in this row, and then everybody here as well, and everybody here as well. And we might have to share. I don't know. Have we gotten calculators in here before? Did everybody have one, or did we have to share? No. We'll try it this way first, and we'll see how many we have left. All right, so I'm going to show you guys how we can use the graphing calculator to get a very, like, the line of best fit. In other words, the actual line that gets closest to every possible point. Somebody wrote a program, but basically, you're looking for a line that minimizes the distance from each point to the line you get it. So let's go ahead and do this. So what we're going to do is we're going to use the graphing calculator first to do this. So once again, you're going to start by clearing your calculator. Second plus 712. Now, I printed out these instructions for you. A lot of times with our graphing calculator exercises, I don't really test you on it. This will be on your test. That's why I printed this for you. You can use this on your test for free, okay? So we're going to follow these steps. So let's practice reading these as we do the exercise so that you'll get used to using the written steps to do the actual steps. You don't need to write anything down that we're doing today. Just want you guys to engage in the process. That's it. So you don't need to write down this example or anything like that. All right, so here we go. The first thing that we're going to do is we're going to enter the data. You guys see where it says enter the data? Okay, step 1 says press the stat button. You guys see it? Press stat. The next one says select edit. So we're going to click 1 for edit. You've got some columns there. It says enter all the X values in the column titled L1 and enter all the Y values in the column titled L2. So my X values are 1. So you type 1 and then push enter. 3, 5, and 9. I'm not going to put the 15 in because there's no Y value that goes with it. That's for part 2 of our question. We'll get to that later. So just 1, 3, 5, and 9. If you've already put the 15 in, just delete it. Just highlight that number and push delete and you're good. All right, next we're going to go ahead and push this arrow key to get over into the Y column. We're going to enter all the Y values. So 9, enter, 6, enter, 4, enter, and 1, enter. All right, so step 2 says let's calculate the line of best fit. So first of all, we're going to exit the data screen. So press second and then mode, and that takes you back to the home screen. Second and then mode. And now we're going to calculate the line of best fit. So step 1 says press stat. So stat. Step 2 says scroll over to calc using the arrow key. So you guys see where it says calc up here? You're going to scroll over to that. Do you guys see where it says reg? That means linear regression. But there's also quadratic regression, cubic regression, etc. But we're just doing linear regression. So we're going to go ahead and push 4 to activate that. And then it says press enter 5 times. Enter once works for me, so there it is. Okay, so what are we looking at? Well, they're not using the same letters as us, but what does the A represent? That's our slope, right? The number in front of the X. So my slope, we'll just round it to the nearest tenths. Well, let's round to the nearest hundredths. My slope is 0.97 and it's negative. And my y-intercept, if I round to the nearest hundredths, is 9.37. And so the equation of my line would be this. That's the equation of the line of best fit. Now something that you don't really need to do, but you can, is you could actually graph all this stuff as well. And so I just included it on here and we have time today, so why not? So on the very bottom is how to graph your data and the line of best fit. So we're going to push second, it says. Part B says press Y equals. It says press 1 and enter. So what we just did is, you know that data we entered in the table? This is called stat plot. So when you push second, Y equals, it takes you to the stat plot page. I'll do it again real quick. And L1 and L2, those were those 2 columns where we put that data. Okay? So what we did was we pushed 1 and we clicked on. So now the data that we plot, it's going to plot them as points on the graph for us. Okay? That's what we just did there. So that's plotting the data points. Then we're going to graph the line of best fit also. So go ahead and push this time just Y equals. Just Y equals, so you should be on this screen. Then we're going to type in our equation. I forgot my X. So negative 0.97. Don't forget, there's a difference between the negative button and the minus button. We want negative 0.97x plus 9.37. After that, we should be good to press graph, and we should be able to see everything. There's the dots. You see those little circles? And then there's the line of best fit that we have there. Okay. So that's the calculator work. You'll need this for your test on Wednesday, so keep this handy with you guys, okay? Now, why do we bother finding lines of best fit? Because we can use them to find and predict other things that we don't know yet. So for instance, if all this data is true, then when x is 15, what is y? Well, it says here, use the equation of the line to answer it. Well, all you have to do is plug it in. This is a what value? It's an x value, right? So I'm going to replace x with 15. And I can figure out what the y value is that would go with that. So let's go ahead and calculate what that would be. What is negative 0.97 times 15? Negative 14 point what? Okay. And then what if we add 9.37 to that?
Negative 5.20.
Like that. And so we now know what would go there. Okay, so when you have a line of best fit, you can use that to predict other values that you don't know yet. Okay. All right, so I'm gonna let you guys practice doing that in the calculators.
I have a question.
Or
can we just press second table for
maybe. Yeah. So Eli's trying to show off his calculator skills here. He knows that you can push table and you can find it. Is it on there?
Yeah.
Does it say 5.2? Negative 5.2?
It was negative 5.1.
Okay, close enough, right? Good. Yeah, so that works. I don't usually use the table one because unless they give you a nice x value like 15, it's usually not there. But like if I had asked for something funky like 14.2, it probably wouldn't be in there. But if you know that and you find it, go for it. That totally works. All right, so here's the same process for you guys. So here's your instructions, right? Start by just clearing your calculator. It makes it easy. You don't have to go through and delete everything. So just do your second plus 712, and then go ahead and see if you guys can get that answer.